Season 3, the opener. The first 2 seasons, we designed the classic systems first, then welded a layer of AI onto each piece. This season's different. We're designing AI-native systems, straight up. The kind of thing that literally wouldn't exist without a large language model. First one up, the thing the most people are building right now, and also the thing the most people get wrong. RAG. Retrieval-augmented generation. Let me paint you a picture first. You built your company an internal Q&A bot, wired up a large language model, and it chats away like a total pro. Then a coworker asks, "How many days till a refund lands?" And it fires right back, 2 days. But your policy says 5 days in black and white. The model isn't broken, and it made that up with total confidence. The problem is, the context you fed it was just flat out retrieved wrong. And that's the one line I want to weld into your brain today. The quality of RAG equals the quality of retrieval. The model isn't the variable. Retrieval is. So let's get it straight first. What RAG actually is and why it needs to exist. In one line. You take the relevant material you searched up and stuff it into the prompt, so the model answers based on that material, not off whatever it's got memorized in its head. Now you might ask, why not just ask the large language model directly? You can't. 3 fatal flaws. 1. Its knowledge has a cutoff date. That policy you changed last week? It has no idea. 2. When it doesn't know something, it'll make it up with a straight face. That's hallucination. 3. Your company's internal docs? It's never seen them. So why not just take those docs and fine-tune, retrain a model on them? Because it's expensive, slow, and a pain to update. Every time a doc changes, you'd have to retrain the whole thing. Nobody does that. Okay, so why not just dump the entire knowledge base into the context window, all at once? If it fits, it burns money. And if it doesn't fit? These days, you've got docs running into the millions of words. No matter how big the window is, it won't fit. And stuff in too much. And the model actually gets lost in the middle. It can't grab what matters. So the answer is retrieve on demand. Whatever the user asks, I go search for the few most relevant passages, and I only stuff those few in.
The whole pipeline is 5 steps. Chunk, embed, retrieve, rerank, generate.
We'll take it apart step by step, and for every step, I'll actually run it and show you how it breaks and how you fix it. Step 1, chunking. It's the least glamorous step, and the one the most people skip. And then they die right here. Why chunk at all? Because you can't treat a whole document as one retrieval unit. That's way too coarse. You've got to cut it into small chunks and embed and retrieve them one chunk at a time. The most intuitive way to chunk. Fixed length. A cut every few hundred characters. Here's the problem. That cut often lands right in the middle of a sentence and splits a complete answer clean in half. And retrieval returns the whole chunk. The chunk with your half answer gets retrieved, sure, but there's only half a sentence in it, so what the model gets is broken. Let's actually run it. A refund policy running a bit over 400 characters, 5 questions, and we check whether each question's answer lands inside a single chunk.
Fixed length chunking. Of the 5 answers, only 2 come out complete. The other 3. How to start a return, gift cards, damaged items. All split apart.
Switch up the chunking. Cut on sentence boundaries and leave 1 sentence of overlap between neighboring chunks.
All 5 answers, whole and intact. 5 out of 5.
There's a deeper trade-off here. Note it down. Chunk too small, and the context gets too fragmented. The setup and payoff of a single point get torn apart. Chunk too big, and you've got 5 different things crammed into one chunk. The embedding vector gets diluted, and retrieval precision drops. And that overlap isn't there for nothing. It exists specifically to rescue the answers that straddle 2 sentences. It keeps a copy in both neighboring chunks. One line. Retrieval quality gets capped before you ever embed, right here at the chunking step. I've seen way too many people tune their embedding model for ages and still can't find something that's plainly right there in the doc. Go back and look, and the answer got cut clean in half by fixed length chunking. Step 2. Embedding plus retrieval. This is the heart of RAG, the main character of today's episode. The core tension is just one line. The user asks in their own words, and the doc was written in somebody else's words. The most basic retrieval is keyword search. It matches shared words. But one paraphrase, one synonym, and the shared words drop straight to 0. Embedding plays a different game. It maps every piece of text into a vector. Just think of it as turning meaning into a point in space. Things that mean similar, things sit close together. Let's actually run it. The user asks, how do I trim my monthly cloud spend?
Keyword search. The top hit shares exactly one word with the question. And the one that's actually the most relevant, slim down your AWS bill. 0 shared words. Doesn't even make the list.
Because the user said trim, cloud, spend, and the doc says reduce AWS bill. On the literal level, not a single word in common.
Vector search. The two cost-cutting entries, similarity 0.96 and 0.93, come right up to the top, rock solid.
Trim and reduce, cloud and AWS, spend and bill, in meaning space they land in the same neighborhood. 0 shared words, and it still hits. As for how the similarity gets computed, it's just the cosine of the angle between two vectors. The more their directions line up, the closer the value gets to 1. You don't need to memorize the formula. Just remember, close in meaning, close in vector. That's enough. This is exactly why RAG uses embeddings, and not grep. Let me give you a more down-to-earth one. In a customer support knowledge base, the user types my thing broke, I want a replacement, and the doc title is defective item replacement policy. Keyword search, not a single one matches. Vectors, catch it in one grab. Real talk for a second. The vectors in this demo are a hand-built concept space, standing in as a stunt double for the mechanism. A real system uses a trained embedding model, but the principle is exactly the same. Turn meaning into a vector, and find by distance. But if you stop here and go vector only, you'll fall into a different pit. Vectors are great at meaning, but they smear out the precise stuff. Error codes, acronyms, product model numbers, order numbers, it wipes them all into roughly the nearby meaning. The other way around, keyword search nails that kind of precise token in one shot, but it dies on paraphrases. Each one has its own blind spot. So RAG in production is hybrid retrieval. You run both, then fuse them. Let's actually run it. 12 documents, and we check whether the correct answer makes it into the top 3.
Keyword search hits only 2. Exactly the 2 with precise tokens, HPA, and the error code E4032. It misses all 3 paraphrases. Vectors are the exact opposite. Hits all 3 paraphrases and smears out both precise tokens.
How do you combine them? With a trick that's dead simple and works ridiculously well. Reciprocal rank fusion, RRF. Each retriever gives a rank, and a document's fused score is just across every list, 1 over its rank, added up. The higher it ranks, the bigger its contribution.
After fusion, all 5 queries. Every one hits.
Don't pick one or the other between vector and keyword. Real RAG wants both. After fusion, there's one more step, reranking. The retrieval layer, to stay fast, hands you a batch that's roughly relevant, and there's noise in it. The reranker switches to a scoring method that's more expensive, but also more accurate, runs it only on this small batch of candidates, and pushes the real answer to the very front. Fast and rough does the coarse pass first, slow and accurate does the fine pick after. This 2-stage thing, recall first, then re-rank, you've seen it in recommender systems too. Exact same idea. Let's run one. The first layer retrieval gets fooled by a decoy that echoes the question's wording but is actually off topic. It ranks the decoy first and pushes the real answer down to second.
The reranker takes one look. Does this chunk actually mention refund or not? One vote, and it shoves the real answer back to first. Precision at 1, from 0 to 1.
Now let's lay the hardest card on the table. It's also the honest card play for the whole season. The quality of RAG equals the quality of retrieval. I said this at the top, and now I'll actually run it for you.
Same question, same model, same prompt template. Give it the right chunk, and it answers correctly. Give it a wrong chunk that echoes the question but is actually about order shipping, and it blurts out orders, 2 days, just as confident.
Watch closely. The model didn't change. What changed is the fact retrieval fed it. Garbage in, garbage out. And it comes out in that same rock-certain tone. So let's run through the 4 questions.
What it helps with. It lets the large language model use your private, real-time data without retraining. Swap the docs, not the model. What it replaces. It replaces taking your data and fine-tuning on it, and it replaces jamming the whole knowledge base into the context. Instead, you retrieve on demand and pull only the few relevant passages. What it changes. The whole system's center of gravity shifts from the model to the retrieval pipeline. Chunking strategy, embedding choice, hybrid weights, re-ranking, evaluation, those are what you're tuning day in, day out.
So where's the line? This honest card, you've absolutely got to take it. RAG gives the model context, not knowledge. It's not that the model learned your data. It just searches fresh on every call and stuffs the results into the prompt. So it's not fine-tuning. Not one weight got changed. And it's not memory. Nothing gets left behind. Next time, it has to search all over again. Retrieve wrong, and it confidently answers wrong. The bottleneck is always in retrieval, not in you swapping in a bigger model. Before we wrap, 5 traps. 1. Don't chunk by brute fixed length. Cut on semantic boundaries, leave overlap, and don't slice your answer in half. 2. Don't go vector only. Precise tokens, order numbers, error codes, product names, vectors smear them, so you need keyword search to back you up. Hybrid retrieval. 3. Retrieve wrong, and the model will confidently make things up. So you absolutely need it to carry sources, to be traceable, with the answer showing which chunk it cited right next to it. Only then can you trust it. 4. Don't skimp on re-ranking. The first layer recall is going for don't miss anything, so its precision isn't enough. You lean on re-ranking to push the real answer up. 5. Don't treat RAG as fine-tuning or as memory. It doesn't change the model, doesn't hold state. Every single time, it searches fresh and stuffs it in. Mix that up, and you'll design the whole architecture crooked. Let me weld one line to close. RAG, when you cut through it, is just search plus stitching the results into the prompt. A 4-step pipeline. Chunk, embed, hybrid retrieval, re-rank, and only then do you hand it off to the model to generate. And its ceiling, start to finish, is pinned at the retrieval layer, not at the model. Notice something? More than half of this is old parts again. A vector store is just a sharded data store, a close cousin of the KV store we designed last season. A cache blocks the repeat questions. A queue handles the offline batch embedding. AI native systems, the foundation is still that same old system design. Next episode, we climb one layer higher. We design an agent platform. When the large language model doesn't just answer, but can call tools, can remember things, can orchestrate multi-step tasks on its own, what kind of foundation do you have to build under it? See you next episode.